Okay, here's the problem that I was working on in class. I'm going to try and show the angles and how you find them. First of all, let me point out that this line right here is 0.5 feet long. So this is an isosceles triangle, and the angle here, theta, is the same as the angle right here. So these are both theta. The angle inside right here, because that's an isosceles, that angle right here is 180 minus 2 theta. So I can find that angle. Because I can find that angle, I can find the angle between the black line and this blue one. And this guy is equal to 180 minus the red interior angle, which is 180 minus 2 theta. So if you reduce that, it's 180 minus 180, minus minus is 2 theta. So this is 2 theta. So that blue angle is 2 theta. Okay, so now I had some forces. One of the forces was the pressure P, which was coming from that circular slot, and that would be along this radius right here, and I drew it pointing in, so that was P. And so the angle that I'm looking for from P in order to resolve it is the angle, let's draw a line across here. This angle right here is 2 theta. So I know where P is. The other one that I had was perpendicular to the slot, which was this direction, to that straight slot, and I called that in. And I'm looking for that angle as well. Also the MG, which was vertically downward like this. This was the MG. Alright, so there's a right triangle in here. Kind of draw it wiggly. There's a leg. There's the leg, and then here's the hypotenuse. So there's a right triangle. And so the angle between, let's see. Okay, so the angle here between the radial direction and the MG, that angle right there, that angle is equal to 90 minus theta. So now I can take the MG and I can turn it into the radial direction and the transverse direction. Okay, so I've got the MG, I've got the angle for the MG. The P is going to be, let's continue the radial direction, because I'm trying to find radial and transverse, right? So there's the radial direction. If the angle between P and the blue line is 2 theta, between the blue line and the red line, that guy is theta. Therefore, this angle right here, right there, is 2 theta minus theta, which is theta. So that gives me the ability to convert the P into the tangent, or not tangent, the radial component and the transverse component. So I can resolve P, I can resolve the MG, and then the N is already lined up. So those are the two angles I need. This wiggly angle right here is theta. The angle between the MG and the radial line right here is 90 minus theta. So those give me the angles that I need for the other. And then you have all the angles then that you need to to sum forces and set it equal to the mass times acceleration. That's it.